Hey class, how's it going? We got hopefully a little bit of an easier week or just less amount of questions and content to kind of look over. We have our last week of momentum and just looking at this idea of elastic and inelastic collisions. You've already actually done a couple of these questions in the last little worksheet when we looked at our conservation of momentum and maybe even some 2D, like 2D momentum. So there's a few of these questions that sneaked in last week. I just didn't really use these words exactly a whole lot. Where this week, let's actually look at them, let's give a little intro, and let's kind of try and use this to kind of see how some questions will differ and how we can approach these questions. So what does an elastic collision means? What an elastic collision means, it means that both kinetic energy and momentum are conserved. Which means you don't lose any kinetic energy beforehand, then afterwards, and you don't lose any momentum beforehand and afterwards. Okay, how's it going? So basically we're looking again. So a good example of this is if I were to take two, on a pool table, if you were to take two pool balls and they were to hit each other, they go off in different directions. All right, the actual momentum and the kinetic energy will be exactly the same. Okay, so elastic collisions usually happen when things actually collide and move in different directions, or collide and go backwards or forwards. But it's when two things collide and don't stick to each other, and they move off in different directions. That is usually where we talk about our elastic collisions, because we don't lose any energy to crumpling or to sound or to heat or to a lot of those things. So elastic, the momentum is exactly the same, so momentum beforehand will be exactly the momentum afterwards. As well, kinetic energy will be the same before and after. Okay? Inelastic collisions, momentum is still conserved. Okay, is conserved. But kinetic energy does not, like kinetic energy initial, does not equal kinetic energy final. Okay, and so this can happen kind of two ways. One, you're either going to lose energy, and that's usually the way. Usually you lose some kind of energy. Like if you imagine two cars hit each other, the front ends crumple a bunch, there's a lot of sound, there's a lot of heat that's generated. The momentum's still going to be conserved because we have that mass. Those two masses join and go away in a certain direction. But the actual energy, a lot of energy can be lost to thermal energy, to sound energy, and to that kind of stuff. So usually, I say usually, your initial energy is more than your final energy. Sometimes though you can get more of a final energy, especially if you get some kind of possible explosion or any extra energy added into an actual collision can sometimes happen, especially when we're dropping things on top of each other. Sometimes you get extra energy from like ground kinetic energy or some kind of like spring action, like you can depress into the ground a little. Nonetheless, we'll leave that alone. We don't have to go into the crazy physics of that. But if kinetic energy before and kinetic energy after don't actually equal each other, that's when you talk about more of an inelastic collision, okay? And most of the time, not always, but most of the time this is when two things collide and then become one thing. Okay, so last week we had cars that crashed into each other and then went off sliding into a certain direction. Also, you might have like, again, a football person tackling another football person where they become one object and they go in a certain direction. Those are usually more classified as inelastic collisions, okay? And so I kind of used these words sparsely last week, but I didn't really explain them. This week we're just going to focus more just on these type of questions, and then I may ask you like, well, even though momentum is conserved, how much energy, like did the energy stay the same or did I lose some? Okay, and then please tell me, is it an elastic or elastic, and try and justify your answer. Okay, so hopefully this kind of makes sense. Elastic, both kinetic energy beforehand and after will be exactly the same, as well as momentum. Usually just glancing collisions. This one, momentum is conserved. Kinetic energy before and after do not match. Usually you lose some, sometimes you can gain some. And this is a lot of time where, again, things collide and then stay together. Okay, hopefully that makes sense. We're going to do, I'll have 3 other videos looking mostly at our practice sheet. There was only one practice sheet for this week because we did most momentum kind of last week. So only one little practice sheet. I'll do 4 or 5 questions in kind of 2 videos looking at these ones. All right, class, thanks so much. Talk to you soon.